Hello, dear students. This is your engineering mathematics 3 lecture. Today we are going to start second unit. The second unit is the topic is Fourier transform. The Fourier transform. This concept is from Fourier integral theorem. Let's see what is Fourier integral theorem. If a function f of x is such that if there are two conditions, f of x satisfies Dirichlet's condition, and second one, f of x is absolutely integrable. Absolutely integrable means integration from minus infinity to infinity mod of f of x dx converges. Then we can represent f of x as integral. That integral equation 1 represents the integral of the function f of x. Now, what is Fourier transform? The concept of Fourier transform. The function f of lambda, that f is capital here, f of lambda is equal to integration minus infinity to infinity, f of u e raised to minus I lambda u du is called as Fourier transform of the function f of x. So you know what is the function f of x? The function f of x which is absolutely integrable and it satisfies Dirichlet's conditions. That function is f of x. And f of x is equal to 1 upon 2 pi into integration minus infinity to infinity f of lambda into e raised to minus I lambda x d lambda is called as inverse Fourier transform. So this is the formula for inverse Fourier transform, and the first one is a capital F of lambda. This is equal to integration or minus infinity to infinity f of u into e raised to I lambda u du. This is formula find Fourier transform of the function. Okay. Now Fourier sine transform. Next term is Fourier sine transform. If a function is defined in the interval minus infinity to infinity and it is an odd function, f of x is defined in the interval minus infinity to infinity and it is an odd function of x, then from the expression of Fourier sine integral, the formula to find the Fourier sine transform is here f of s lambda, f suffix s is for sine transform. This lambda is equal to integration or 0 to infinity f of u sine lambda u du. Then the inverse Fourier sine transform is given by the formula f of x is equal to 2 upon pi integration or 0 to infinity fs lambda into sine lambda x d lambda. Is to find the inverse Fourier transform, inverse Fourier sine transform, we require the Fourier transform, Fourier sine transform. Then we can find its inverse Fourier transform. See here, fs lambda gives the Fourier sine transform of f of x, and f of x gives the inverse Fourier sine transform of fs lambda. That suffix s is for sine transform. Okay, so these are the two results of Fourier sine transform and inverse Fourier sine transform. Now next concept is Fourier cosine transform. If a function f of x is defined in the interval minus infinity to infinity and it is an even function of x, then from the expression of Fourier cosine integral, here we can write a formula fc lambda c. Fc lambda suffix c is for cosine transform. It is the formula for cosine transform is equal to integration for 0 to infinity f of u cos lambda u du. Then f of x is equal to 2 upon pi into integration for 0 to infinity fc lambda into cos lambda x d lambda. This is inverse Fourier cosine transform here. Epsilon lambda gives the Fourier cosine transform of f of x, and f of x gives the inverse Fourier cosine transform of f of x. So these are the results for cosine transform and inverse Fourier cosine transform and inverse Fourier cosine transform. Okay. Now the examples on Fourier transform. Here discuss three results. First one is for general function, which is neither even nor odd. For that function, the formula to find the inverse, sorry, the formula to find the Fourier transform is here. F of lambda is equal to integration minus infinity to infinity f of u e raised to minus I lambda u du. This is the formula to find the Fourier transform when function is neither even nor odd. Then the formula to find the inverse Fourier transform when it is neither even nor odd. It is f of x is equal to 1 upon 2 pi integration or minus infinity to infinity f of lambda into e raised to I lambda x d lambda. Okay. The next is Fourier sine transform. When function is odd function, then the Fourier transform is called Fourier sine transform. Its notation is fs lambda f suffix s lambda. And the formula is integration over 0 to infinity f of u sine lambda u du. And inverse Fourier sine transform, its formula is f of x is equal to 2 upon pi into integration over 0 to infinity fs lambda into sine lambda x d lambda. Okay, next Fourier cosine transform, its formula is fc lambda f suffix cc for cosine transform. It is equal to fc lambda is equal to integration of 0 to infinity f of u cos lambda u du. And then the inverse Fourier cosine transform, its formula is f of x is equal to 2 upon pi into integration of 0 to infinity fc lambda into cos lambda x d lambda. Okay, so there are three concepts: Fourier transform, Fourier cosine transform, Fourier sine transform, and their inverses. So there are total six results. Now the examples based on these six results. The first example is here. Find Fourier cosine transform of f of x is equal to, function is defined into intervals, is equal to cos x when x is in between 0 to a, and if the function value is 0 when x is greater than or equal to a. Now we are going to find the cosine transform. Here directly the heading is find Fourier cosine transform. So no need to check whether it is even or odd. We just find the Fourier cosine transform. Now the formula for Fourier cosine transform is fc lambda f suffix c lambda is equal to integration over 0 to infinity f of u cos lambda u du. Now, what is the function here f of u? Here function is in the form of x, means variable is x in the given example. You just replace that x by u, then you will get f of u. It is f of u is equal to defined into intervals. Function is defined into intervals. Is cos u when u lies between 0 to a. So you split the integration over 0 to infinity because a is the point of discontinuity. So 0 to a and a to infinity. So epsilon lambda is equal to f of u. F of u here is cos u. Cos u in cos x, you replace that x by u, so that you will get cos u. So your function f of u is cos u when limits from 0 to a. Cos u into cos lambda u. Now multiply and divide the term by 2. Here we are multiplying by 2, so divide it by 2 also, so that you will get your original function. Plus integration for a to infinity. When limits are a to infinity, the function value is 0. So the second term is 0. Now we are multiplying and dividing the term by 2 because we are going to use here the formula 2 cos a cos b. See, what is the formula for 2 cos a cos b? It is cos of a minus b plus cos of a plus b. So cos of a minus b is here. Cos of a minus b. A is here lambda u, b is here u. So lambda minus 1 into u is common, plus cos of a plus b means lambda u plus u is common, so in bracket lambda plus 1. So this is the product formula 2 cos a cos b. We are using to split this product cos u into 2 cos u cos lambda u. So 1 by 2 as it is. In the bracket, integration was 0 to a, 0 to a, 2 cos a, cos b, 2 cos u cos lambda u. Its value is cos of lambda 1 minus 1 into u plus cos of lambda plus 1 into u. Let it complete into d. Now there are two terms. You separate both the terms and then integrate 1 by 2 as it is. What is the integration of cost function? The integration of cost function is sine lambda minus 1 into u upon lambda minus 1 plus, again second term is cost function. The integration of cost function is sine lambda plus 1 into u upon lambda plus 1. Because the integration is with respect to u, so variable is u. And so lambda in first integral, lambda minus 1 is a constant term, and in second lambda plus 1 is a constant term. So you write the coefficients in denominator while integrating, and the limits are 0 to a. So fc lambda is equal to 1 by 2 into. Now put upper limit a. Now variable is u because integration differential is here du. So integration with respect to u. So you replace the variable u by upper limit a. So sine lambda minus 1 into u, you replace that u by upper limit a. Sine lambda minus 1 into a upon lambda minus 1 plus sine of lambda plus 1 into a upon lambda plus 1. Lower limit is 0. So put u is equal to 0. Sine 0 is 0 plus, sorry, lower limit is 0. So give negative sign for lower limit. Minus sine 0 is 0. Again, second term negative sign minus sine 0, 0. So when we put lower limit 0, we are getting both the terms zeros. So your answer is here. Fourier cosine transform is 1 by 2 inside the bracket sine of lambda minus 1 bracket complete into a upon lambda minus 1 plus sine of lambda plus 1 into a upon lambda plus 1. So this is your answer.